All right, welcome to my section tonight, everybody. In Jackson, we're gonna rock this out. We got two fantastic speakers tonight,
Woohoo!
and we're also gonna be trying out a wireless lapel mic. Whether this goes well or terribly, we're gonna find out. We're gonna find out. The transition period will be really interesting. But with that, I'll hand it over to you, sir.
All right, my name is Douglas Dew, and tonight I'm doing my talk over the things they don't teach us in college. And actually, this was really reinforced by last week at GrrCon, where we had a lot of people come up to us that were fresh out of college. They just gotten their degrees, and they're like, "How do I get a job in the field?" We're like, "We're the wrong people to ask." But what do you want to do in the field was our kind of questions. And they're like, "I don't know. I don't know what the jobs look like. I've never heard of a SOC. I've never heard of a CSER. I've never heard of anything to do with the field." So we get a lot of that, where there's people that just didn't know anything about the actual tech field outside of the college environment. So that's what my talk is over. So when you go to college, you work hard, you study hard, you do a bunch of stuff, and you think, "Yay, I got A's, I did all my assignments, I did the extra activities, I know my stuff." And then you go for an interview and you realize that you have no idea what the job is. They give you the title of the job, of what you're applying for, and you have no idea what's going on. You don't know what you're supposed to be doing, what they expect from you, what you would be doing if you got hired in. So, sort of know what I'm doing. So when you first get out of college, you realize that, and you get your first tech job, you realize that they never taught you how to be smart. They taught you all this stuff about VMs, they taught you all about different operating systems, but then you get in a room with a bunch of other security people that have, I don't know, 5 minutes more experience than you do, and they're all of a sudden talking about things like PII and SCADA systems and all sorts of other material, and you have no idea what they're talking about, and you can't follow them, and you can't sound smart too. You can't keep up with them, and you realize that, wow, they taught me all this stuff in college, but they didn't teach me how to be smart, how to talk the talk, how to get along with these people. And then one of the other big things they don't teach you in college is they don't teach you how to be dumb. So you get in there, and your boss gives you an assignment, or other people are talking about assignments, and they're telling you about this something that's 10 levels in depth that is way past what you've ever heard about, and you're sitting there nodding your head saying, "Yeah, I know exactly what you're talking about. I completely understand." But see, they never told you that everybody knows that you don't know anything. You have to be dumb. It is okay to be dumb in our field. There's way too many very, very, very intelligent people and way too many very smart people that go very far in their careers that you're not going to have any clue about. And then it's okay not to know the answers. And it's okay to say, hey, can you wait a second? Can you back it up? Can you repeat that? Can you tell me that again? I have no idea what you're talking about. Can you explain what that acronym is? They didn't tell us that. And they think, "Oh, wow, I got this degree. I paid all this money for this college. I'm supposed to be a worthy employee." And you don't realize that there's way more information in this field than you can ever really embrace within a college lifetime. And one of those kind of things that I wish somebody would have told me about this. I wish I would have known. All through my college days, I had no idea what a SIM was. I had no idea about any of the major software packages, major appliances, maybe some PA stuff, maybe heard about Cisco, knew some Cisco stuff, some Cisco code. Never actually got to handle any hardware. But you don't know what a SIM is. A Security Information and Event Management Center. And a lot of the starting jobs, a lot of where people get their level 1 jobs, are working with SIMs. And it'd be nice if you were going into an interview to get a job where you're working on a SIM, if you knew what one was. Or at least maybe if they told you in college, "Hey, this is what the acronym is, this is what it means." So when they ask you, you're not like, "Yeah, I used to play Sims all the time. I had the little family, and they kept burning the house down," and other wonderful things like that. Yes. Yes, there we go.
It's actually very similar. You get trapped in there very quickly.
It is astounding how similar, yeah, wow. One of the other things that I had no idea about until a friend of mine who I was also in college with, he goes, hey, I just got a job in a SOC. And I'm like, great, good for you. What's a SOC? I mean, to me, that's what you put on your foot. They never tell us in college. A SOC, or ISOC, Information Security Operations Center, it's where a lot of our jobs also are, and it's where you'd be working on your SIM, is in a SOC. And it's where all the security information comes together. It's where everything in security comes together. It's like the central command for security. But they don't tell us anything about that. They don't tell us what it looks like. They don't tell us who's in there, what your job titles would be, what is expected of you.
What would you say that you do in a SOC?
Yeah, they don't tell us that. They don't tell us that. You want me to tell you, or?
Yeah.
Okay. Well, just from the fact that I don't work in a SOC, but I get to spy on Kyle here quite a bit. Yes. I get to see it when he says, oh, what is this person up to? Why have they been flagged in the system? Why did Doug do something bad and send off 200 alerts? And you go into their computer and take a closer look and find out what they're running and what's happening and why is it setting off security alerts. And then you're like, okay, it's fine. Or you say, oh no, this is bad, or a major event happens, or anything to do with security. Anytime security is breached, anytime you're also creating alerts so that way you know when bad things are happening. But it's good, Kyle? Yeah? Okay. Again, I don't work in a SOC, so which you'll like the next one because it's a CSIRT, which Kyle does work in. And a CSIRT is kind of just, it's another one of those things they don't teach us about, and actually I didn't know much about until I came here. Never got to see one, never got to talk to anybody that worked in a CSIRT until meeting this wonderful gentleman. And it's kind of like when a SOC gets really, really well developed, then evolves into a CSIRT, or can have a CSIRT as an added-on additional feature. It's just a special group of people that are instant response. So instead of having one person that would be your instant response, you could have an entire team of people that have specialized skills in that area. Correct? Yeah?
You're missing the instant in that response team there.
Oops. Oh yeah, and I have very bad PowerPoint skills. That's another one they didn't teach me in college. Golly, they could have done that one.
So,
Which is why we get a lot of white screens.
So what have you seen so far the difference between your SOC and the CSIRT? So
What?
The skill sets involved in either one.
What I've seen is a lot of the SOC work seems to be very passive, where the CSIRT, I feel like the CSIRT is more of like you guys are taking action, and when something happens, you guys just swing into going on. It's much more of like a IDS versus IPS. I feel like that's from my perception of it. So. Oh, SCADA. SCADA. So I had never heard of SCADA before speaking with Ben Carroll, who works here. He's talking about SCADA and how that's everything he works with, and that's his whole job. And I'm like, how is there an entire position for something that I've never even heard of that's in our tech field, it's in our security field? And then reading a book on Stuxnet, and all of a sudden you're like, holy dang, SCADA's a big deal. It's kind of a big, why didn't they teach us about this? So anything that is water, light, nuclear, missile silos, those kind of things, you're going to have SCADA, you're going to have PLCs, and that's sort of like, let's see, how do we put this? It's the entire security infrastructure for things that are mission critical. And they don't tell us that. They don't tell us what it is. They don't tell us how it's different. They don't tell us anything about it. And I really wish they had. I wish somebody at least thrown an acronym up there and told me, hey, kid, go look this up, because you might see it someday in the field, which you're going to see it in the field. Even if you're not directly involved, you're going to hear about it in the news. You're going to hear about all the bad things that happen when things go wrong with SCADA. And once again, I don't work with these systems, so I'm not the best person, but I wish somebody had told me that, hey, this exists. So that, yes, exactly. Oh, contractors. And that is the closest picture. I should have gotten a picture of Kyle. Kyle from Deloitte before yes, Kyle from Deloitte, our consultant before, but that's like the happiest guy I could find. So I figured that was close enough.
It's actually really good for contractors in general. That's
Yeah.
spot on, I think.
That's what I was thinking too, is that like contractors they seem to be very good people skills, very social, very definitely come in with a smile. So, but contracting is also a big deal in our field. And I had never heard of a contractor outside of like carpentry work. You know, the guy you contract to come in and do your plumbing or your electrical or something like that for your house when you're building it. Besides that, I had never heard of a contractor. I'd never heard of a consultant. I didn't know what they did. I didn't know that, hey, they were a thing in our field. But contractors or consultants, they come in for a limited amount of time, and you're hiring them for their skills. So like if you have a job that takes a specific set of skills that you don't want to hire somebody on full time for, as a full employee that you're going to have for years, you could have a contractor come in for a month or 6 months or a year, and they take care of that job for you. And that's actually a very big part of our field. And you can fly around, get a chance to travel if that's what you're into, just by being a contractor. And that is the end of my talk. Questions? Or how about this? Is there anything that, holy dang, I wish somebody would have taught me in college, tech-related, that you got into the field and were all of a sudden starry-eyed and had no idea what people were talking about? Is there anything like that with you guys?
So, did you ever have anyone explain like the difference between like red team and blue team and how there's more jobs in a certain field, like even that hard?
No. Yeah, no, nobody did. Red team, blue team, purple, and then there's black hats. Yeah, I didn't know what all the colors were, all the different hats were. Yeah, they didn't tell me that.
Schools have a habit of, like, you know, oh, red team's super cool. Go do red team because it's fun.
Yes.
And they kind of, as kind of what James was talking about, they don't really give you that thing of like, hey, you know, there's more jobs in blue. It's easier to get into that. And red teaming is not as fun as it sounds. And they leave out all the fun stuff you can do on blue team side because they just throw red team at you because it's in the news.
Yep, that's definitely true. Actually, I don't know, I think blue's pretty fun too, so. But how about acronyms? You guys ever, sorry, Kyle, you going to say something? Okay. You guys have any acronyms that somebody threw out to you like day one or first couple weeks in, and you know, you're like, gosh, it's been a week and I've mentioned that 300 times. Maybe I should ask what the heck that is or try to look it up. Any acronyms you guys heard a lot? They were just like,
I feel that's going to be every company you go into, depending on what that company's doing, whether it be insurance, power, manufacturing, you're always going to have just tons of acronyms that come in.
yes.
You know, when I first came, one of my first jobs, they actually gave you a book that was like 15 pages, like small print, that actually had all the acronyms detailed out. You know? And then they stopped
Wow.
keeping up to date, and it was useless because the acronyms that were in there are already outdated and not used, and they had new ones that actually describe the same things. So,
Then you have acronyms within something that, like, there's other acronyms that mean something different that are spelled exactly the same. It's the same set of letters.
yeah.
Mm-hmm. Like Mac. Yeah.
There's a lot of that. Probably and getting into your first job too, you run into stuff where, as you were talking about before, you don't know everything, but you're being asked to jump into basically the hot seat.
Yep.
So you learn quickly that, you know, trying to do as much as you can, just using Google. You know, don't be ashamed of it or anything. Be like, oh, you're dumb because you use Google. No, everybody uses Google.
Everybody uses Google, yep.
That gets you a starting place and moves you forward a little bit. And then from there, you know, when you get actually stuck, you can move forward and ask a more detailed question because at least you did something in it.
Mm-hmm.
And most companies, especially when you're coming in new, they want to see that first. So.
A lot too is like, please don't be afraid to stop people when they're talking about something that's completely going over your head. Like, hey, can you break this down? Can you explain to me what's that mean? What's this mean? Or say, hey, I have no idea what you're talking about, and just sort of just smiling and nodding, because there's some smart people in this field, and a lot of them realize when you're just pretending to be smart. So it does not pan out, and you don't learn nearly as much. You can't soak in as much. So there's a lot of questions that need to be asked, especially when you're starting out. Anything else anybody else has that's like, gosh, I wish they would have told me about that. I wish I would have known that back in college. I wish I would have known that about the field. I wish that would have given me better forward thought. All right. That's my talk. Mm-hmm.
Next up, we'll have Leah.
Yay.
You should tell people that. Welcome back.
Okay.
Yay, they can do a cafe.
Okay. Ready? All right, welcome back. Really overwhelmed by the crowd today. Not going to name any names. Hi, my name is Leah. If you didn't already know, I know most of the people in here. So today I'm going to talk about Git. Is there anybody in the room that actually uses or know what that is? You do? One person. That's fantastic. So let me pull up my PowerPoint. Kind of, sort of, not quite. Git is kind of an extension off GitHub. It is a version control system that will track the history of your files. So if you're working in a directory, you make changes and realize, oops, that was a bad thing, you can use GitHub to kind of rewind and look at previous versions of your files. So I have a directory on my desktop that we are going to make a Git directory. And there's a couple different ways to do this. I prefer the bash command line, but you can also use Windows command line or a GUI interface. So let me clear the screen. So I have a directory here called cool code, and usually Git is used for code because there's just so many changes you can make, so many things you can do wrong and you want to reverse back. So most people use this for Python, PowerShell. So let's take a look at my directory. I have a hello world.txt, and I also have another directory, cd into that guy, and in here I have two more files called more code and a readme. So I'm just going to cat, that didn't help.
You catted hell.
Yes, I think it'd be.
I know, I'm trying the tab complete, and tab complete isn't working for some reason.
Yeah, I think it'd be out of the library.
Oh, duh, okay. There we go. Let's clear my screen. Start over. All right. So this one just has a little bit of Python code. If I cat code, let's try the readme file. This just says put really cool code in these files. And cat my more code. This also has just a little bit of Python code. It happens to be the same as the hello world.txt as well. So I'm going to do a really complicated command here that's going to make this a Git repository, which is git init, enter. That's all you have to do. But it does say my Git repository is empty. So if I do a git status, it's saying that my files are untracked. And I'm going to jump back to my PowerPoint. And there's 4 stages of Git. And right now, we are before the, we're in the untracked stage, which means Git isn't tracking these files. It doesn't really even know they're there. It's just ignoring them. So we want to take them from untracked to the staged stage of Git, where it's going to track the files, but they're not part of a version of Git yet. So to make a version, we want to commit the files, which is basically version 2.0 for your repository. And then once you're ready, you can push those files up to the cloud in GitHub. So jump back. And let's add our files. So we do another really complicated command, git add file name. Do that for hello world. And if we do screen, git status, we can see that our files are ready to be committed. So let's do our first commit, git commit -m for message, and we're going to do first, if I can type, commit. All right, and I can jump back to my PowerShell. Actually, I don't want to do that. All right, so now if we do a git log, you can kind of get an idea of what's going on here. We have a commit with our commit message, the date, the author, and also this hash value. And this is when Git gets kind of interesting, because we can take this hash value and take a peek at it. With git cat file -p for print and our hash. Can everybody read this? Do you want me to blow up the?
You get a little bit bigger. I think it's on the screen. It's a little tricky to see, but
Let me go.
yeah, I'm seeing it.
There we go. All right. So since we've peeked into this hash value, we get even more information. We got our message again, the committer, the person who made the commit, the author of the repository, and our tree. So our tree has another hash. Let's figure out what that is. So we're going to take our hash value, do another git cat file, and we have a tree and a blob. And with some deductive reasoning, we can conclude that a tree is basically a directory, so we can see that's our code library, and a blob, which is fun to say, is the data within a file. So if I were to cat file this hash right here, it would be our little bit of Python code from our hello world. And if I cat this guy, we'll go one more layer deep. Git cat file. We're going to see our two files that were inside code library. And also note that morecode.txt is the exact same hash as hello world. So let's take a look at this. We're going to go here. And this is kind of what it looks like. So we have our commit, and then we have our directory cool code. And then if we have our code library, and then our blobs. And hello world and more code are both pointing toward the same blob. So that's kind of cool, and Git, it's not going to store the same information twice. So if two things equal the same value, it's just going to point to that same blob and maybe save you some room on your local machine if you're using a really big project. So, fancy. Okay, so let's go ahead and make a change to our repository, and we'll make a new version. So I'm going to go ahead and open this guy, and let's add some code. Maybe input, what is your name? And if we do git status, we can see that our file was modified. So we'll do git add hello world status. Take a look. We're ready to commit. Test message, add name input. Okay, so now if we do clear git log, we can see both of our commits. Our first commit was push down one, and add name input was put to the top. And we can also see that it's the head, meaning it's the one that our repository is currently looking at. And I'm going to just take a peek at this guy real quick, because there is going to be a little change from the last time. So git cat file. And it's all the same information except for our parent right here. Our parent is the exact same hash as our commit of our first commit right here. So it's just pointing back to its previous version of the file. So let's say I wanted to view the file from a previous version. So I want to take a peek and see what changed. I can do a git show, and then I want to grab this hash right here. And, oh dear. Let's try that again. Git log, git show. Here we go. And I'm going to tell it what file I want. So I want my changed file, hello world. And there's my previous version of the file before I had made any changes to it. If I discovered that I made a horrible change and just wanted to revert back to the previous version of the repository, I can do git reset, let's see, -- hard reset, and I'm going to do head squiggly line 1. So what this does is it's telling go from the head and reverse one version. So right now I only have 2, so I don't have to worry about going back 3 or 4 versions. So, and I have a successful commit. And if I do git log, I only have the 1 commit. So I got rid of the bad code that I didn't like. All right. So if I wanted to make changes to my original file, but I didn't really want to mess with the integrity of it, I could do a branch. So I can create a branch. Let's take a look. And I only have 1 branch, which is the master branch. So if I wanted to create a new branch, I'll do git branch, and then the name that I want to associate it with, branch 2. And I do git branch again, and we see that we have that second branch. But if I made a change to the file right now, it would only make the change to the master branch because I'm on the master branch, and I can tell because of the green right here, the asterisk, and also my little note right here that tells me what branch I'm on. So to change my branch, I can do git checkout, branch 2.
Just let you know that the stream is fine, but this screen is actually cut off a little bit.
Do I need to move it? This?
You move it a couple, yeah.
Slightly to the center of the screen.
Yep. Then we can see it. Yeah.
There we go. All right. All right, do git branch, and we're on branch 2. All right, so now that we're pointing at that branch, I can make a change. Let's go to more code. Let's say we wanted to put in a name. What is your name? Maybe an age as well. Go all out. What is your age? Save my code. can do a git status, see that our file is changed. So we can do git add code library, more code, git commit dash message, and h. Okay, so I just made a commit on branch 2. So I can pull up my PowerPoint and let's take a look at what that looks like. There you go. So both of our commits are different now, so they kind of branched off of each other, and I'm on the head branch, which is branch 2. So what if I decided I liked my code, I tested it, it works well, and now I want my master branch to be updated to the new code? I can do a merge. So I'm going to clear, and I'm going to check out, go back to my master branch. I'm switched to master, and then I want to do git merge with branch 2. And I do git status, nothing to commit. Can go back and look at my more code and see that it's updated to my new code that I had put into the branch 2. And that's basically all I had planned. Is there any questions, comments, concerns?
That was awesome. That's
Okay.
So I've got one question.
Yes.
So it makes sense that you can track the history stuff, but why
Right.
would this be useful?
Do you code any?
Yeah.
Okay. Have you ever had code that works and you add code to it and find out later that, oops, that didn't work?
Yeah, it breaks everything.
And it breaks everything. So you try to go in manually and remove all the broken code, but that can be complicated and time consuming. With this, you can just kind of reverse with just a couple commands and get back to your good code.
Okay, makes sense. So
Yeah.
it's good for personal projects, like stuff I'm working on?
Yeah. Yep. And it doesn't have to be just code either. If you're working on recipes or family photos, or
Yeah,
it can be anything. Yeah.
So each time you want to start a new project or change your code, you create a new branch?
If you want to. That kind of gives you, your branch is kind of like your expendable crewman. That's how I think of it. Like, you can do anything to that branch, you can break it, mess it up, and if it turns out it doesn't work, you can just get rid of it. Or you could do it where you change the original file, and then if you decide you don't like it, you can just hop back to previous versions of the file before you made those changes.
Yeah, I missed part 2. How did you get to this terminal, this Git terminal?
It's Git Bash, and there's actually a couple options you can use this with. So we can use, well, that didn't help. Let's see. Git Bash uses Linux. We can also use Git GUI, which I don't like as much, but that's an option too if maybe you're less technical. I just want to use this for personal use.
So I'm curious then, if you had this Git repository on like your local NAS, is it cross-platform?
Yes. So you can use this on a Linux box.
Yeah, you'd be writing out some Python code on your Windows box, and then all of a sudden jump on a Linux laptop and get on Git, and then it's working.
Yep.
Okay.
In that case, you would probably clone your repository back onto your other laptop. So if you had 2 machines, the actual repository is in the cloud in GitHub, and there's a URL.
Just working straight off the NAS.
No, yeah, that too.
So you got some great high fives from the Slack channel, by the way. So that you nailed a complicated topic and presented it in an easy to follow format.
Was that Hillary? No. Oh, okay. All right. She told me she'd be watching.
So awesome job.
Cool. All right. So, any more questions? Awesome. All right.
So-
Yep.
Another question. So this was Linux and you were putting some Python code in there as well?
Well, just the command line is Linux. You can use a Windows command line too.
Okay.
And the code really doesn't matter what's in the code. It can be anything. Yeah. Okay. Good. Cool. All right. How do I turn this off?
And something I completely forgot to talk about in the beginning of this was an announcement about.
Oh, yeah, the RUCTF. So every year in December, we do a CTF in Southfield. In order to prepare for that this year, we're actually going to have a workshop beforehand. So if you guys are interested, the Baker College of Auburn Hills is going to host us on October 4th at 5:30. If you guys are interested in coming out, you can join us and get set up for the CTF, which is going to be in December, I think.
Yeah, sounds
That
good.
hasn't been released yet, but usually the first week in December.
Cool. All right, that's all we got for tonight. Everybody have a wonderful night and adios. But not really, because I have to walk over here and turn this off. Trying to figure out where the button. Nope, that's. Hold on. What?
Knock the camera
Oh,
over.
yep. Let's make this complicated.